In this video, we're going to discuss inverse trig functions as well as solving right triangles. Inverse trig functions are used to undo trig functions. These undo sine, cosine, and tangent. So recall that sine, cosine, and tangent, these functions, the sine, we do the sine of some angle, and this spits out a ratio. So we have a sine, we plug in the value of the angle, 0 degrees up through 90 degrees, or up through 180, I should say, and that spits out some ratio or some decimal. What these inverse tangents do are the exact opposite. So these will take in, we'll say the inverse of some ratio, and that will spit out what an angle is going to be. There's two different sets of notation for these inverses. There's the most common one that you see in your calculator are just to note the inverse. It's the same function, but with a little what looks like an exponent of -1. So like this little -1 is the symbol for the inverse, and you can see that in your calculator if you pull up, say, on an Inspire. If you click on the Trig button, it's right below the sine, cosine, tangent of -1, as well as these other trig functions that we're holding off for another course. There's also, you'll sometimes see this as the inverse. It's called the arctangent, or similarly, this inverse sine, or inverse cosine, or arc sine, or arc cosine. And again, all of these take in the same ratios or decimals that you would have used in sine, cosine, tangent, that you would have gotten out of a sine, cosine, tangent. We plug those into these arc functions, and what we get out are angles. We're going to use these to solve right triangles, or to find all missing parts. When we say solve a triangle, that means find all the missing sides and angles. Okay. I'd like to show you how to use these inverse tangents, these inverse functions, both on an Inspire as well as on just on a plain old scientific or just calculator from Google, to work on at home. And then in the next video, we'll actually solve some triangles completely. So let's see, I want to use the calculator to find the missing angle measures to the nearest tenth, so 1 decimal place. There are two missing angles in this triangle, angle A and angle C. It doesn't matter which one you find, just choose one, and then we'll find the other one pretty quickly afterwards. Maybe I'll start with A because it's a little early in the alphabet. So from angle A's perspective, I want to use sine, cosine, or tangent to write a trig ratio. So from angle A's perspective, I think we know the opposite leg, and we know the hypotenuse. And from our previous lesson, the trig function that uses opposite and hypotenuse is SO and SOHCAHTOA. So I think the sine of whatever angle A is opposite over hypotenuse, or 24 out of 25. If I want to undo this this sign, I want to use the inverse function. So just like if you want to undo a square by using a square root, and there's plenty of other examples out in math that do this, I'm going to do the same thing here. Instead, to undo the sine, I'm going to do the inverse sine of both sides. Inverse sine and sine undo each other, and we're left with just whatever the measure of angle A is, because that was what's on the inside. So angle A is just the inverse sine of whatever 24 divided by 25 is. On my calculator, the inverse sine button is in the same place as the sine, as trig functions. You need to be in degree mode in order for this inverse sine to spit out an answer in degrees. If you're not in degree mode, you can get there by hitting dock, and then settings, dock, settings, and document settings and making sure your angle is reading degrees. You can tell that because there's DEG in the top right-hand corner. And I'm going to do trig, sine inverse, that's sine minus 1, and then I'm going to write the fraction 24 out of 25. I'll do control divide 24 on top and 25 on the bottom, hit enter. And in degrees, this angle whose sine ratio is 24 to 25, the angle in degrees that does that is 73.7398, or to the nearest tenth of a degree, I think that's 73.7. To find angle C, you could do the similar thing from angle C's perspective. The sides you know are not the opposite hypotenuse, but the adjacent hypotenuse. So you could use inverse cosine to find it. Or, since we know two of the three angles, we know the angles of a triangle always add to 180, we could just use subtraction. And I know, now that I know two of these three angles, I know the measure angle C is whatever 180, take away 90, take away this 73.7 degrees is, which works out to be about 16.3 degrees. Try that again on the second triangle. Pick either one of the angles you're looking to find. It does not matter which one, A or E. Maybe I'll use E in this case because I used the top one last time. I'll use the bottom one this time. It doesn't matter in any way. From E's perspective, we know two of the sides. What are they? That's the opposite side and the adjacent leg. Opposite and adjacent, that's the OA, that's the TOA of SOHCAHTOA. So I think the tangent of angle E is equal to opposite over adjacent. And again, I can undo tangent by using its inverse. So I think of doing the inverse of this trig function on both sides. So I think the tangent and inverse tangent undo each other, and we know the angle E then is equal to the inverse tangent of 20 out of 21. I'll do this on just a calculator on Google, just to show you how to do that if you don't have aren't able to download the student calculator in Inspire, or you haven't yet, or for whatever reason can't. In my Google calculator, I just Googled calculator. What do you know? Make sure that I'm in degrees, so I'm going to make sure the degree button is highlighted, so I'm measuring angles in degrees. I want to do the inverse tangent of 20 out of 21. Normally, sine, cosine, tangent up. If you hit this INV button, that'll bring up the inverse functions, and there's our friend inverse tangent. So inverse tangent, and the calculator displays as arctangent. As I mentioned before, that's another way to say it. I'll type in 20 out of 21, so 20 divided by 21. Hit enter. And it tells me that this angle is about 43.6028, blah, blah, blah. Or this is about 43.6 degrees. Again, I'll find angle D by subtraction. So then the measure of angle D is 180, take away 90, take away 43.6, which makes it about 46.4. Angle D and angle E. Lastly, C is the acute angle in a right triangle. If it helps to draw a right triangle, you can draw it. It's not really necessary though, because we're just trying to find what angle C is. If you know the sine, cosine, or tangent, that means that angle C in each of these cases is just the inverse of whatever function is presented. So I just want the inverse of 0.24. If you want to type 24 divided by 100, you can, or just this decimal, 0.24 will work. On my Google calculator here that's already pulled up, I can do inverse sine of 0.24, hit enter, and that works out to be to the nearest tenth of a degree. The tenth place is the first decimal place, about 13.9 degrees. Cosine of 0.37, so angle C is the inverse cosine of 0.37, which is about inverse cosine 0.37. about 68.3. And I'll do the last one on my Inspire. This one should be angle C is the inverse tangent, because tangent's the function that's here. 0.54. Again, I'm in degree mode, so I'll hit Trig inverse tangent of 0.54, enter, and it's about 28.4 degrees.